This is Rizzy. It says we're trying to solve the 2024-2025 exam question maths 209. All right. If you have any question you want to ask me, please reach out to my WhatsApp number 09058669385. It says using the Newton-Raphson's method, it said compute, and I'm solving number 1A. Using the Newton-Raphson's method, it says compute and correct to 4 decimal place the root of the equation. And so this is the function itself, x to the power of 3 minus 6x plus 4. First of all, we have to quote the Newton-Raphson's law, which says that this is the Newton-Raphson's law. Xn plus 1 is equal to xn minus f of xn divided by f prime of xn. Very, very interesting for us to note. Now, if you look at the question properly, you discover that there was no interval of operation given. There was no interval of operation given. Is that correct? So we have to do what? We have to find the interval of operation. We have to find the interval. And so we begin to do what we call trial and error. We begin to find numbers that can, give us one negative and one positive. Is that okay? We call that the Descartes rule of signs. The Descartes rule of signs, where we have one negative and one positive. It says f of a multiplied by f of b must be less than 0. That is the Descartes rule of signs. So let's figure out the interval of operation. What do I mean by interval of operation? The two numbers such that they are a and b, such that the answer is in between a and is in between b. Do you understand me? So, all right, let's go. So trial and error, we want to try at -1. At -1, what's it going to give us? So you plot your calculator, you write the equation itself, and you press calculate for me at -1. You have 9. That's why you have it as 9 here. Then you try for 0. You calc at 0. Calculate for me at 0. You have 4. You see, that's why you have it as 4 here. Again, you come again and calc at 1. Calc at 1. You have -1. You see that? -1. So at this point, at this particular stage, we have a positive figure, and at this particular stage, we have a negative figure. It means that f of 0, when multiplied by f of 1, is less than 0. What do I mean? Because if you say 4 times -1, your answer is less than 0, because that you're having -4, which is less than 0. So now that you're able to get one positive, one negative, it means that, you see that, this means that our interval of operation is 0 and 1. That means the answer that I'm looking for is in between 0 and is in between 1. Is that clear now? It's in between 0 and is in between 1. So now that we have been able to do that, we now begin to say, okay, I can now decide to choose a figure between 0 and 1. And what are the figures between 0 and 1? I have 0, I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 until I get to 1, right? So I begin to pick any number of my choice. So I want to pick the middle, 0.5. Do you understand? So now I say step 3. I say you see that x0 equals 0.5. Do you understand? So I say, what is f of x0? What is f of x0? F of x0 here will be, let's calculate, what is f of x0? So calc at 0.5. If you calc at 0.5, you're going to have 1.125. That's 1.125. Do you understand? So now, what is the differential of this function itself? The differential of this function is, you have f of x to be, your f of x is x to the power of 3 minus 6x plus 4. If you differentiate this function, f prime, if you differentiate this function, right, it's going to be 3x squared minus 6. I hope you are aware. 3x squared minus 6. So now, what is the f of x of this? So what is the f prime of x of this function? That means when you put this, what's it called, 0.5 into the differential, what's it going to be? You now begin to say what? You now begin to say 3 into bracket 0.5 all squared minus 6. Is that not? And so your answer there will be minus 5.25. Is that not? So now your x1, you have gotten x0 now. X0 is 0.5. Look at it here. X0 is 0.5. Your x1 will be your previous statement, which is x0 minus f of x0 all over f prime of x0. Did you see that? That will be your x1. So your answer here now. So for us to stop beating around the bush, right? For you to stop beating around the bush, let me assume that, now check this out. On your calculator now, right? I want to use the calculator method to make this thing easier. To make it what? Easier. So on your calculator, you're just going to write x minus, you write the equation itself. If you are using the RIZZY'S method, for you to make everything easy for you on that day, minus divided by the differential of the equation. Divided by the differential of the equation. Do you understand? Now, what do I mean? Let's look at it. Let's look at it together. X minus the equation itself now. The equation itself is x to the power of 3 minus 6x plus 4. Let me divide it by the differential of the equation. 3x squared minus 6. That's all. You understand? So that I will stop wasting my booklet, right? Because here now, for me to continue from here, I have to do x1 is equal to 0.5 minus f of 0.5 divided by f prime of 0.5. And then I'll begin to solve again and find an answer. So for me to stop wasting my time, I just need to go to my calculator and press this. I'll press alpha x minus, do you see that I put a fraction sign? I'll write the equation at the top. You see, alpha x to the power of 3. You see that? You see, x to the power of 3. Okay, minus 6x plus 4. That's the equation itself. And so the differential of the equation will stay down. 3 alpha x squared, right? Minus 6. Now that you have done this, then you now calc at 0.5. You know our x0 was 0.5. Calc at 0.5. You're going to be having what? 0.7142. So let's write calc at 0.5. So our x0 now, which is 0.5. Our x1 is 0. Let's check it out. Let's check that out. Check it out. 0.71428. 0.71428. Right? Now our x2, for me to stop, so I'm going to impute, this will be my new value now. I'm going to impute this now. Calc at this to give me this. Calc at this to give me. So I keep repeating that process so that I stop wasting my booklet. You understand me? So x1 now is 0.71428. Do you understand me? Now x2 will be, now check this out. You go back to your calculator and press calc at 0.71428. Is that not? What will be your answer? 0.73189. 0.73198. Okay. 0.73198. You see that? So calc at x3 now. What will be your x3? This new answer, I'll calc at this particular value. Calculate this thing for me at. So I press calc at answer. I'm going to have what? 0.7321 at x3. 0.7321 at x4. At x4, let's go again. Calc at answer. At this answer. At this answer, you have 0.7321. You see? 0.7321. So instead of you to stop wasting your booklet, so that you stop wasting your booklet, you can just approach it this way. First of all, get the interval of operation. Second of all, once you have gotten the interval of operation, choose any value. That is if they did not give you an interval of operation. Choose any value between the interval of operation that you just got, which is, for example, 0.5, 0.6. Choose any one and then start solving. Do you understand? Start solving. Let that person that you chose be your x0. And so when you choose your x0, then you start solving from there. Your x1 will be x0 minus f of x0 over f prime of x0. Your x1 will be, as you are going, you are using the previous statement. As you are going, you are using the previous statement. Do you understand? So x0 is 0.5. x1 is to get x1 you calc at x0, you get this one. To get x2 you calc at x1, you get this one. To get x3 you calc at this x2, to get this one. To get this one. So anytime you have done it repeatedly and the answer is the same, like x3 and x4, now look at it, the answers are the same, it means your root is that answer. Do you understand me now? So it says compute to 4 decimal place. So we are on the right track. To 4 decimal place, it means that this means that to 4 decimal place, comma, says the root of the equation, the root of that equation is 0.7321. That is it. So don't forget, on that day, because you are using your calculator, you just write a big X minus, you understand, the equation that they gave you. Any equation that they give you, write it at the top, divided by the differential of that same equation, you write at the bottom, and then you just calculate whatever x naught you have. You calculate it, you keep calculating whenever it repeats itself. Once it repeats itself, that's the answer. Whenever you keep copying and your answer repeats itself, that is the answer. Is that okay? All right. So that is that about number 1. Then we move to number 2. Okay, so we continue. It says assume that the exact value of the given equation in 1a. That means this particular 1a, this particular person here, it said the exact value. Our final answer for 1a is 0.7321. Here you go. 0.7321, right? It now says assume that the exact value of the given function in 1a is x is equal to 2. That means they assume that this person is x is equal to 2, no more 0.7321. So it says determine the absolute error. What do we know about absolute error? First of all, to solve, let's solve solution to 1a, solution to 1b. What do we know about absolute error? We found out that absolute error is equal to the true value minus the approximate. Is that not what we know? Yes, that's good. Minus the approximate. So what is the true value? The true value now, we assume that the x was equal to 2. So that will be our true value. Minus what is the approximate value? Approximate is 0.7321. So this is going to give us 1.2679, right? 1.2679. That's the absolute error. Absolute error is true value minus approximate, right? So that's the absolute error. It says, what is the relative error? What is the relative error? Is that not? And we know that relative error is absolute error over what? Over exact value. That's what we know it as. You know that absolute error over is divided by exact value. So we say 1.2679 should divide the exact value, which is 2. Our answer to that will be 0.6340. You see that? It's as simple as that. What is the percentage error? Percentage error. We found out that percentage error is relative error multiplied by 100, right? So the relative error that we know is 0.6340. 0.6340. Let's multiply it by 100 and find out what we got. Our answer is 63.40%. You see? 63.40. So now, question number 2. Let's go to question number 2. It says, let's read the question out. It says the general, let me use a black pen. It says the general recursive formula for finding the root of Rx is equal to 0 is given by xn plus 1 is equal to Rxn. It says as x naught is equal to alpha, initial guess. Initial guess. It says state the convergence. It says state the convergence. Wow. It says state the convergence criteria near the root. That's a very interesting question. Now this brings us back to fixed point method. Here, let's write. The solution to this is that we are talking about the fixed point method. We're talking about the fixed point method. And you see, in the sequence of fixed point method, let's write in fixed point method, we discover that that the sequence, you see, in fixed point method, we discover that the sequence xn plus 1 is always equal to g of xn, and then it converges. Let's write that out. That's the answer to that question. It converges if the absolute value of the differential of x is less than 1 for all x in the interval containing the roots. So in the fixed point method, what we are saying, for example, if I give you 3x to the power 3 minus 6x plus 4, in the fixed point method, the first thing to do is to find subject of formula. Get the subject of formulas in this question. You have to derive the subject of formulas from this question. If you say x raised to the power 3, you can say x raised to the power 3 minus 6x is equal to 4. You take minus 4. Then you say x into bracket x squared minus 6 is equal to minus 4. You divide both sides by x squared minus 6, divide both sides by x squared minus 6. That's iteration 1, iterative scheme 1. So after getting the subject of formula in fixed point method, here are the steps. Number 1, you get the subject of formulas available. Number 2, you differentiate the subject of formulas that are available. Number 3, you check, which of these differentials such that if I impute the value, it's going to be less than 1. You understand? And then you begin to pick that particular subject of formula whose differential is less than 1. And then you continue from there. But don't worry, we're going to look at the question from it very soon. Very, very soon, very interestingly. All right, so the answer to that is that the sequence xn plus 1 is equal to g of xn. It converges when the absolute value of the differential, we usually call this the Leibniz theorem, due to Leibniz rule. So, but that's not what we are going to today. We have solved question number 2a. Okay, the second part of the question says that, okay, that's 2b now. I want to solve question 2b. Question 2b. It says, assume, so let's do that. It says, assume that r of x is equal to 2e to e minus x plus x. It says, show that there is a real root between 1 and 2. Wow, that's very interesting. So it shows that there is a real root between 1 and 2. So what do we do? All right. So how do we operate a fixed point method? This is a fixed point method. Yes, because question 2b was emanated or was derived from question 2a, So let's use using the fixed point method to solve this particular problem. Solution. All right. So what is f of 1? F of 1 means 2 e to the bracket 1 plus 1. All right. So if you do that, f of 1 will be 0.28117. What is f of 2? 2 minus e to the bracket of the power of 2 plus 2. That is exponential, right? That would be minus 3.3891. So this is a positive, one negative, right? These two people these guys have proved Descartes' law. So we can say since f of 1 when multiplied by f of 2 was less than 0, it means Descartes' law was proved. Descartes' law was proved, right? Because Descartes' law says that f of a, by the time you multiply it by f of b, your answer must be less than 0. So Descartes' law was proved. All right. Now, if that's the case, let's continue from there, right? So we have, if I want to rewrite this, I can easily say I don't like it when a number starts a equation. So I can easily just rewrite it and say, okay, let's continue from there. So step one, we derive the subjects of formula available from the equation itself. We derive the subject of formula available from the equation itself. Is that okay? So when you have, for example, you have 2 minus ex to the power of x plus x is equal to 0, right? Now, if I want to make solve the formula of x here, first of all, I can say this x now, I can say x is equal to e to the power of x minus 2. So it's just like me bringing this person to this side and bringing this person to this side. So e to the power of x minus 2. Is that out? Which other subject of formula can I have? This is subject of formula 1. Subject of formula 1. Which other thing can I do? I can decide to say, okay, x plus 2, I'm bringing this one over, x plus 2 is equal to e to the power of x, and then I take the ln of both sides, right? Let's take the ln of both sides. Take the natural log of both sides. If you take the natural log of both sides, you are simply saying ln x plus 2 is equal to ln e to the power of x, right? And if ln cancels, so you are simply saying ln x plus 2 is equal to x. That's subject of formula 2. Abi? Now, so is that you have x is equal to e to the power of x minus 2, or you have ln x plus 2 is equal to x. Those are the two subject of formulas that you can have. All right, so let us see. So now step 2. So let's do step 2. We differentiate each subject of formulas. What is the first subject of formula? We have e to the power of x minus 2. That's SOF1. Please, SOF means subject of formula. So SOF1. And SOF2 is, what is SOF2? ln x plus 2. That's subject of formula 2. So let's differentiate this person. So let's differentiate. So differentiating SOF1 now, subject of formula 1. If we differentiate this guy with respect to x, of course, there's only one independent variable that is there, which is x. So if we differentiate that guy with respect to x, I believe what you're going to be having is you're going to be having what we call e to the power of x. Yeah, your answer is e to the power of x. I'm differentiating this, so guys, e to the power of x is still e to the power of x, because when we want to differentiate, if you say e to the power of ax and you want to differentiate, this coefficient comes down and say a times e to the power of ax. So it's the same thing. So when you differentiate e to the power of x, you're going to have e to the power of x, because the coefficient in x here is 1. So that 1 comes down. 1 multiplied by e to the power of x is e to the power of x. Is that not? All right. Secondly, we are differentiating SOF2 with respect to x also. Okay, so SOF2 states that ln x plus 2. How do we differentiate this? You say let, from your math 102, you say let x plus 2 equals, for example, p. You now say y is equal to ln p, right? So the y, the p is 1 over p, and the p dx, I'm differentiating with respect to x here, the p dx is 1. So it means that from chain rule, dy dp should multiply the p dx, is that not? And what is dy dp? 1 over p. Let's use it to multiply the p dx, 1. So our answer is still 1 over p. Let's recall that p was what? X plus 2. So 1 over x plus 2. So it means that the differential, so the differential 1, differential of the first circuit of formula, the differential of SOF1 is what? What's the differential of SOF1? Is e to the power of x. And the differential of SOF2 is what? 1 over x plus 2. That's the differential of SOF1, differential of SOF2. So now we check step 3 now, right? We're in step what? This is step 2. Step 3. We check such that we have, when you differentiate this, it will be less than 1. Okay, so this particular one, e to the power of x, let's impute at x naught here. We're going to have e to the power of what? What's the x naught you want to use? Since they said the interval of operation exists between, look at it, the question says exists between 1 and 2, right? So I'm choosing I say let x naught now be 1.5. The middle of 1 and 2 is 1.5. So let x naught be 1.5. So e to the power of 1.5, I believe that answer will be greater than 1. Yeah, I believe it will be greater than 1. You can confirm that it will be greater than 1. So I'm not going to use that, so it is wrong. So we are testing each differential at x naught. Do you understand? We are testing each differential at what? At x naught. So I believe e to the power of 1.5. Let's check that out quickly. I'm not sure, but I believe it to be more than. So e to the power exponential, where are you? Exponential to the power of 1.5. That's 4 point whatever it is. That's 4 point whatever, and it is greater than 1. So no, we are looking for something that will be less than 1. Do you understand? So we check again. We want to check at 1 over x plus 2 at x naught. That's 1 over 1.5 plus 2, which is 1 over, what is 1.5 plus 2? That's 3.5. What is 1 divided by 3.5? What is 1 divided by 3.5? 1 divided by 3.5. We have that as 0.285. 0.285. And you see, 0.285 is less than 1. So this one is approved. This guy is approved. So after finding out whose differential is less than 1, you now go back to the subject. So step 4 now. So since g prime of x1, which was less than 1, is this particular person, 1 over x plus 2, which was less than 1, we choose the sort of formula that arrived us at this particular person. We choose the subject of formula. That arrived at this differential. We begin to choose the formula that arrives at. So What sort of formula gave us this particular thing? What sort of formula did we differentiate to give us 1 over x plus 2? What sort of formula was that? ln, see that? This guy. ln x plus 2. Do you understand? ln what? X plus 2. So we say, we choose a sort of formula that arrived us at that differential, which is what? ln x plus 2. Do you see that? So now let's start. Our x naught is 1.5. You know, I chose the middle as x naught. X naught is 1.5. Look at it here. So now what will be our x1? Our x1 will be ln 1.5 plus 2. You understand? And which is ln 3.5. ln 3.5 is 1.2528. So x2 will be ln x1. You know your x1 is 1.2528. So me now, for me to save myself of all this stress, I quickly go to my calculator. I go to my calculator and press, see that? You go to your calculator and press ln, you write x plus 2. You understand? You cover it. You say calc this value for me at 1.5. I have 1.2527. You come here and write it 1.2527, approximately 1.2528 anyway, 28. Now what will be this value? X2. You say calcat, you see, calcat your answer, calcat ans your previous answer. That will be 1.1795. That will be 1.1795. x3 ln x2. You see? So calcat ans. You see that? 1.156725. So that would be 1.156725. So I'm just doing it in 4 decimal place, you understand? X4. You go back to your calculator. X4. Calcat answer. You see? 1.1495. X4 is ln x3. 1.1495. What about x5? Let's do x5. x5 1.15 1.1495. I mean calcat answer, sorry. The other will be 1.14725. Okay, ln x4 1.14725. Is it 725? Check it, confirm it. 725, so 73. 1.14725 73. Do you understand? So now x6. Let's x6 ln x5. So calcat. So you say calcat your previous answer. Calcat your previous answer. It's taking time. It's taking time. Okay. In the absence of that, let's calcat 1 point. So calculators sometimes can can malfunction, right? X plus 2. I know you understand the picture of what I'm trying to do, right? ln x plus 2. We are calculating at 1.147. Let's check that. 1.1473. 1.1473. Calculate this. You are going to have 1.1465. You're going to have 1.1465, right? So calculate again. Calculate answer again. Calculate answer again. You're going to have 1.1463. 1.1463. x7 ln x6. 1.11463. So invariably I can just say that what my answer to this, since I have 1.1465, 1.63, 1. So I know that my answer will fall in the category of 1.146 something, right? So I can just divide these two answers, divide them by 2 and pick my choice so that I stop wasting my time. You understand? 1.1465 plus 1.1463 divided by 2. All these decimal places is due to approximation, you understand? So let's just do that quickly. 1.1465 plus 1.1463 is what? Divided by 2. Let me just find the middle ground. 1.1464. Do you understand? So I know that 1.14. So the root, I can now say the root of the equation. Root of the equation is 1.1464. Do you understand now? So that is it. Is that clear now? I think that's better. All right. So normally I'm supposed to keep doing this until the answer I get is the same thing with the previous answer I get, and then I stop. But to save yourself of stress, some people now will solve this thing and have 1.1465. Some will solve it and have 1.1467. You guys are all correct. As long as you what? As long as you follow the procedure. As long as you do what? You follow the what? Procedure. All right. The next question is it says Lagrange polynomials, Lagrange interpolation. All right, we're gonna do that in our next video because of time. That's a very long what's it called? That's a very long approach, very long approach. So we're going to do that in our next video. Evaluate the integral of 0 to 1.2 x 1 plus x squared minus 1. I already solved that in one of the videos. So let's just do this one. Number 5. Number 5 says that consider the given population. It says consider the given population below. Given population table below. Okay, it says here, it says population. Okay, so we have 1951, 1961, 1962, 1963. Oh, sorry, 1962. Sorry, 1961, 1970. Sorry, 1971, 1981, 1991. Wow, interesting. So it says at this point we have 98752 132285 168076. We have dash here 240060. Consider this population, and it says estimate the population of 1981. Estimate the population of 1981. Number 5A says estimate the population of 1981. Wow, this is very interesting. Very, very interesting. Let's look at this together. You see, this is of equal interval. We're talking about interpolation to solution. This question is interpolation of equal interval. Interpolation of what? Equal interval. Because what's the difference between 1951 and 1961? 10. What's the difference between 1961 and 1971? 10. What's the difference between 1971? So everybody is just taking 10 as their interval, abi? All right. So so let's label now. So step 1. So we're looking for 1981. 1981 is in this category, abi? 1981 is close to the end of the table. So since since we are looking for the population 1981, which is close to the end of the table, we use NBI. We use what? NBI. We use what? NBI. Is that okay? 1981, we use NBI because we are close to the end of the table. Newton backward interpolation. Do you understand me? Okay. So, step one. Let's construct the difference table. Let's construct the what? The difference table. Let's construct it quickly. Let's construct the difference table quickly. So here I'll call it one x, not x not x. Sorry, x. I'll call this one y. I'll call this one backward difference of y. Call this one backward difference squared of y, backward difference cubed of y. So the x values, I'm going to arrange them here: 1951, 1961, 1971, 1981, 1981, and 1991. So the y values, I'm going to arrange them here: 98752, 98752. We have 132285. We have 168076. We have, so we don't know. Okay, so we don't know this particular guy, right? Okay. So we know one. We have 240060, right? Okay. So let's just erase this part, the part that we don't know. Let's just erase this part. So let's do this quickly. Oh, the video is getting